Okay, everybody, welcome back to school. Today we're going to start talking about trigonometry. We're just going to do the basics. Trigonometry is very intricate, but I'm going to teach you guys the very basics so that next year you guys can really understand it when you see it, and you'll be that much more ahead than the rest of the pack. Now, in order to understand trigonometry, you must first familiarize yourself with the following terms or concepts. Okay, these are very easy terms and things that you have probably seen in middle school already, but I'm just going to hopefully fine-tune them and really help you understand them. First of all, guys, a line, okay? Anyone thinks they know what a line is, but if you really ask them to define it, they probably can't. And a line connects any 2 points and continues past both points for infinity. So you have 2 points here, A and B. A line is simply something that connects both of those points and continues forever, hence the arrows. Okay? That's what a line is. A line continues on both sides forever. Now, you can go like that. That is a line. It's connecting 2 points. Go that way. That's a line. We know that from graphing, right? You have positive slopes and negative slopes. You have a line like that. You can have a vertical line. Okay? So a line connects 2 points and extends past those 2 points for infinity. Infinity being forever, guys. Now this little symbol right here, let me make it a little bit larger for you so you can see it. That's line AB. Okay, again, we're not in geometry, but I want you to understand how to label things correctly. Line AB, please notice that you have 2 arrows at the end. Believe it or not, that makes a huge difference. Okay? If you don't put those little arrows at the end, you're going to have what's called a segment, which is what we're going to talk about next. A line segment is a part of a line which is contained between 2 points. So in this case, notice the difference here. There are no arrows, okay? Why are there no arrows? Because the segment is contained between 2 points. It's from point A to point B. It's that line in between there. Does not extend beyond those 2 points. Okay, that is what a line segment is. Pretty ridiculously easy so far, right, guys? Okay, that's what I thought. Array. Array is a part of a line that begins at one endpoint. And then it does extend beyond the second endpoint forever for infinity. The way you write array is, right here, look at it. Array AB. Check out how this works, though, please. Notice that you have 1 arrow only. The other side, you have no arrow. It's an endpoint, okay? You always read, no matter what direction this is going, you always read array from the endpoint. So here, endpoint A, it goes through B, so it's AB. This does not necessarily mean, though, that the ray is pointing to the right. For example, I could do this, guys. I could say that's AB, and I promise you, you still write it like that. You do not write it like this. AB going that way. That makes no sense. That is wrong. Okay? I don't want you guys to make that error. That error messes people up all the time. So I don't care if the ray is going to the right or to the left. You always write it endpoint to the point it's going through and an arrow going to the right, regardless of whether it's going left or right or up or down. I saw a hand over there. You sure, my man? Yes, sir. No, remember what I just said? You start with the endpoint. So look, let me show you. Let me show you what I mean. If I have this right here, and this is C and D, that's ray CD. But if I have it going this way, guess what? That's still ray CD. Because it goes endpoint first, and then the point that it's going through. You feel me? Thank you, sir. Does everyone understand that? Sir? Okay, if it was like this, let's say, and that's a B and that's an A, then that would be end point to the point that it's going through. If it was like this, and that's a C and that's an F, bless you, that's going to be ray CF. You always read it from the end point to the point that it's going through. End point to the point that it's going through. Thank you, guys. These are great questions. Does that make sense? Promise? Okay. No? You got it? Yep. Okay. All right. Now, the ray is the really important one, believe it or not, for our purposes here. Because an angle, my friends, is created by two rays. In fact, it's created when two rays have the same end point. Okay? And when they have that same end point, it is called a vertex. And an angle is created as a ray rotates around its end point. Okay? Trigonometry is all about rotation. All about rotation, going around an angle, around a circle. Okay? Rotations. Just keep that in mind. We're going to talk about that more now. So, I have an angle here. This little blue dot, that's where the rays connect. And that's called my vertex. Okay? Inside the angle, this little area right here, that denotes the angle. And this is angle A in this case. Why? Because it's labeled A. That's how an angle is formed. It is two rays that have the same endpoint. Two rays that have the same endpoint. We good so far, guys? Pretty simple, right? You've seen all of this before, right? Pretty much? I'm sorry? Oh, I apologize about that. How is an angle written? Actually, you can write an angle a few different ways. We're not going to get too crazy into it, but it would be written as such. Okay? Be written angle A. Or when you have other points, you could write it a couple different ways, but we'll wait for you to get to geometry. Actually, you know what? Let's do it right now. Let's say this is B and this is C. Okay? You can have angle A, or you can write this as angle BAC, or as angle CAB. So there are three ways really to write any angle, not just this angle here. If you have labels, okay, of the other points on those rays, you could write them any of these three ways. Straight up, you could say, hey, it's angle A. Boom, done. Or, reading from B, you go, well, this is BAC. Done. Or, reading from angle C, this is CAB. Done. Three ways to write an angle. Yes, sir. You cannot do ABC because the middle letter is the angle. Thank you. Great question. The middle letter is the angle. So you cannot write angle ABC here because that would be telling the reader, hey, reader, B is the angle in between the two rays. Does that make sense, guys? Yes, sir. Yes, you would still use the angle symbol, regardless if it was obtuse or acute, which we're going to get to now what obtuse and acute are. Does that make sense so far, my brothers? Okay, thank you. Now, all right, don't get too crazy here. Don't get stressed out. I just do have to start talking to you a little bit. This is just the basics about how angles move, okay? And an angle moves as it rotates around the common vertex or the common endpoint. When you start an angle, you start here, this green line right here. This is called the initial side. The initial side is always the x-axis. It's where you're starting. Okay? And not necessarily always the x-axis. It's just where you're starting. Now this line here, guys, is going to literally rotate. It rotates counterclockwise. When you have a counterclockwise rotation, you are going to get a positive angle. When you have a counterclockwise rotation, you're going to have a positive angle. When you have your initial side is still right here, right? When you go clockwise, you have a negative angle. And where the angle stops is called the terminal side. So back to the positive angle over here, the green one. I have my initial side, and I rotated, and I stopped right here. That's my terminal side. And here is the angle that I have created, theta. Yes, sir. No, I'm going counterclockwise on the first one. Go ahead, son. If you go clockwise or counterclockwise 360 degrees, you get back to the initial side. Yes, sir. Okay? When you go clockwise, it is negative. Guys, remember, clockwise goes like this, and counterclockwise goes like this. Okay. All right, so we know that if we go counterclockwise, we're talking about a positive angle. If we go clockwise, we're talking about a negative angle. And just so you guys can visualize what's going on, because sometimes it's a lot easier to visualize things, let's just go ahead and put this here. And then let me clone that sucker. And then let me go ahead and do this here. Okay. Alrighty, that's what I want. I'm going to make it a little bit longer, and I'm going to make it red so you can see what's going on here. Okay, guys. I'm at my initial side, okay, and the angle is rotating counterclockwise. That's how angles move. If I do one full rotation, it's 360 degrees, I get back to the initial side. So for this case, it rotated, and it stopped right there. That's a positive angle. That is a counterclockwise rotation. Yes, sir. Oh, straight line is 180 degrees. Yes, sir. Or a straight angle, either way. A line or a straight angle are the same thing. Does that make sense, guys, how this angle is rotating? Huh? And then if I go counterclockwise, it's negative. I'm sorry, if I go clockwise, it's negative, right? Yes, sir.
If you went clockwise 185 degrees, that would be a positive.
No. If I went clockwise 185 degrees, here's 180, and then let's say that's 5. No. I have a negative 185 degrees. I went clockwise. If I go clockwise, I create a negative angle. If I go counterclockwise, I create a positive angle. Thank you. Great questions. Yes, sir. It will always show you which way it goes. For example, the question was, how will we know if it's positive or negative? They'll have something like this, and that's positive. Or they'll have something like this, and that's negative. Thank you. Thank you, thank you, thank you. Great questions, guys. Anything else so far? These questions are phenomenal. I really mean it. Thank you. Now, the size of an angle, my friends, is measured in degrees. And an angle formed by one complete counterclockwise rotation has an angle measure of 360 degrees. If I go ahead and I rotate, here's my initial side, and I rotate 360 degrees, that means that I went one full rotation, okay? One full rotation going from initial side all the way back to initial side. It's going to be 360 degrees. If I were to go negative, we're going to do that in blue. I went one full rotation, then I would have gone negative 360 degrees. Counterclockwise, positive. Clockwise, negative. I know it's counterintuitive. I know it is. I'm sorry. It does it does confuse people, but that's the way it is. So one complete rotation is 360 degrees. Half a rotation, my friends, is 180 degrees. 180 degrees, okay? That's a line. When you have 180 degrees, it's a line. So a straight line is also known as, aka, a straight angle. And a straight angle has an angle measure of 180 degrees. Is everyone with me so far? Okay. And a quarter of a rotation is 90 degrees. Okay? Everyone with me? All right. Now, types of angles. You have a right angle. And a right angle is an angle that measures exactly 90 degrees. I showed you what a right angle would look like as a quadrant, as a fourth of a circle. Okay? That's a quarter of a circle. That's a quarter rotation. 90 degrees will always have that little box there. That's a right angle. That denotes 90 degrees. That lets you know, hey, this is a 90-degree angle. Okay? It's called a right angle as well. An acute angle. An acute angle, it's a cute little angle. It's an angle that is less than 90 degrees. Yes, sir. I'm sorry? If it goes negative, it will also be acute, yes. But we're not going to worry too much about negative angles right now. We're going to take baby steps. I just want you to know what the difference between a positive and a negative is. But yes, whatever works for the positive side works for the negative side as well, sir. Okay? But you won't ever really have an angle in real life that has a negative degree. You'll have a negative degree angle in trigonometry when we use applications. But as far as an angle goes, no, you won't see on the SAT, is this an acute angle, and they'll have negative 40 on it. It's a little bit different than that. Okay, thank you, son. Does that make sense? Less than 90. Okay, greater than 0, but less than 0, but greater than 90. And what is this? What am I doing here? What am I doing here? No, yeah, I was right. Yeah, more than 90 and less than 180 is going to be an obtuse triangle. And an obtuse angle. An obtuse angle would be something like this. Okay? That's obtuse. Greater than 90, but less than 180. Has to be greater than 90 because a 90-degree angle is a right angle. Has to be less than 180 because a straight angle is 180 degrees. So obtuse is greater than 90, but less than 180. And if I go back to acute real quick, it's less than 90, but it has to be greater than 0, yes. Has to be greater than 0. If it's not greater than 0, it's not an angle. Complementary angles. I'm sure you've heard about these before too. Complementary angles are angles that have a sum of 90. Okay? 58 plus 32, that's 90 degrees. And this works awesomely because sometimes you'll have questions like this. They'll have this, and they'll say that's 42. Find the missing value. What are you going to do there? 90 minus 42 is going to be 68. No, not even close. 48. Be careful. Think, my brother. Okay? Supplementary angles are angles that add up, have a sum of 180. Supplementary angles are angles that form straight lines or straight angles. 139 plus 41, that's going to be supplementary because 139 plus 41 equals 180 degrees. I can do something similar as well. I can say Okay, that's 80 degrees. Find angle x. It's going to be 100 degrees. Very good. Simple stuff, basic stuff, but these are the things that a lot of people forget. So that's why I want to make sure that we have a good grasp of this. You with me so far? Okay, triangles. The sum of the angle measures of any triangle will always equal 180 degrees. Something you really got to memorize. If you have a triangle, there are 180 degrees inside of that triangle, period. There is not one exception. If you have a three-sided figure that has a total angle measure of 179.9999, that is not a triangle, period. Okay? Has to have 180 degrees. Now, that's just common knowledge. Now, let's go from there to the Pythagorean Theorem. Let's talk about right angles and side measures and all this stuff. All of this is building to trig, which we will start heavier tomorrow. So I know it's easy, but just bear in mind these are the basics. The Pythagorean Theorem, my friends, uses right triangles. And it's a very powerful formula that allows you to solve for the sides of right triangles when given two sides. When you have a right triangle and they want you to solve for a missing side at this stage of the game, they're going to give you two sides. Either both legs, and the legs of a triangle represent the base and the height of a right triangle, and or a leg and a hypotenuse. And the hypotenuse is the longest side of the right triangle, always, period. And it is also the side which is directly across the 90-degree angle. Okay? Pythagoras came up with, well, he didn't really come up with it. He just perfected it. By the way, Pythagoras did not invent this. He came up with the use for it. He's awesome and he deserves the name. But the Babylonians are really the ones that came up with this. Yeah, the Babylonians. The Babylonians were one of the three starting civilizations of Earth, if you guys know your history. And they are the civilization that lived off of the Tigris and Euphrates River. Okay? And Babylonians did math in what's called Babylonian cuneiform. Cuneiform is a base 60. And they had two symbols for their math. A filled-in triangle and one like this. And that's how they did their math. Crazy cool stuff. Anyways, the Greeks found these tablets, and of course Pythagoras could decipher the tablets, and from that he saw this Pythagorean theorem that he became known as a Pythagorean theorem because he, like I said, made an application for it, made a use for it. He made a formula for it that everyone could read. So that's why it's called the Pythagorean theorem, not because he invented it. And the Pythagorean theorem states that c squared, which is the hypotenuse squared, equals a squared, which is a leg squared, plus the b squared, which is the other leg squared. That's it, literally. Okay? That's how you find sides, missing sides of a right triangle. Yes, sir. It does not matter which one's A or B, sir. This could be A, or I could put A here, and I could put B here. Because yes, because the legs are still going to be squared. So it doesn't matter where your A or where your B is. It does not matter. Your C absolutely cannot change. Yes, sir. Okay, very good question. Is it a coincidence, he said, that is the same formula that you use to find the focus parts of a parabola? It's not a coincidence. There is a reason behind it. Remember that when we're talking about conics, we're talking about a cone, right? And in cones, you have rotations. And it's a lot more complicated than that, but yes, it's not just because, there is a specific reason why. Okay, now how do you use this? Find the length of the diagonal of the given square. Okay, well, if it's a square, what do we know about all the angles of a square? Not only are they the same, but they're 90 degrees, right? You did know that, right, guys? Because there's 360 degrees divided by 4 angles that are equal, it's 90 degrees each. So, okay, this is my C. So C squared equals A squared plus B squared. Oh, that was an ugly number. I don't like that. So C squared equals 128. You solve C by square rooting both sides. Technically, it equals plus or minus, but can you have minuses for sides of triangles? So even though it is a plus or minus, we know that algebraically the negative one doesn't work here. So this is 2 times 64. So square root of 64 is 8, square root of 2. We already learned how to reduce and simplify radicals, so that should have been Mickey Mouse for you. So C will equal 8 square root of 2 units. Literally, that's the Pythagorean theorem. Okay? Sometimes they give you a leg and a side. Well, same thing. Okay? I want to find the side A. Well, apparently they gave me side B is 5, so this is A. So 13 squared equals A squared plus B squared. So that's 169 minus 25. So I got 144 equals A squared, square root both sides. Yes, I know it's plus or minus 12 algebraically, but we can't use a negative for a side. So A will equal 12 feet. Mickey Mouse, right? Mickey Mouse. Last thing and we're done for the day. Okay? Special right triangles. Now, special right triangles are called special right triangles for a reason. There are 2 types of special right triangles. There's a 45-45-90 and a 30-60-90. A 45-45-90, when you have an angle, a triangle, that has 2 base angles that are equal, their base sides are also equal, this is called an isosceles triangle. When 2 base angles and 2 sides are equal. Since 2 sides are equal, we're going to call the sides S and S, because they're equal. The hypotenuse of a 45-45-90 is always the side length times the square root of 2. Always the side length times the square root of 2. Okay? The side length times the square root of 2. Period. So, for example, if I've got a 45-45-90, I say this is 8, and I want you to find x and y. X would equal 8, because they're equal, and y would equal 8 square root of 2. Done. You feel me? 30-60-90. A 30-60-90 is also a special right triangle. One thing that you should know is that whenever you have angles and side measures, the smaller the angle, the smaller the side. Remember that. The smaller the angle, the smaller the side. Remember how we said that the hypotenuse is always the largest side? Well, isn't that because it's across the largest angle? Does that make sense? Okay, so the small side of a 30-60-90 is across the 30. And that we call just S. That's just the smallest side there is. The hypotenuse is 2 times that side. The hypotenuse is 2 times the side across the 30. So 2S. And the side across 60 is the side times the square root of 3. Sometimes people say, oh, how do you remember that? Well, 30-60-90, don't I have 3 different angles? And don't I have 3 different sides? Square root of 3. For the 45-45-90, don't I have 2 equal angles and 2 equal sides? Yeah. That's how I remember it. Okay? As far as how to use a 30-60-90, let's say I tell you this. So this is 30, that's 60, and I say that's 8. What's the side across 60? 8 square root of 3. And what's the hypotenuse? 16. Done. One more thing real quick. Let's say I give you this, guys. A 45, 45. But I want you to find x and y. But I say this is 8. What is the equation for the hypotenuse of a 45, 45, 90? So doesn't 8 equal the side times square root of 2? Well, guys, divide by square root of 2. You know how to rationalize already. Multiply radical 2 to both top and bottom. So that's going to be 8 square root of 2 over 2, which is 4 square root of 2. So x equals 4 square root of 2, and y equals 4 square root of 2. Does that make sense? Perfect timing. God bless you. Homework is valid. Come pick it up today in this room, C14, after school. God bless you all. Have a great day.